these two expressions are equivalent. So here I am trying to get to the result that the part at the highest depth in terms of braces around an expression is reversible in the order in which they are executed. That is to say that I can either do this part last, the braces, last at depth equals 2, or I can do it at depth equals 1 and depth equals 0. Okay, in this case I get, it's not reversible. It's only reversible in this special case when I have two expressions that operate on each other. It should work when my function is recursive. Here I'm switching to using bar parentheses here instead of depth. If the measure of n equals n or 0, and the measure of n minus n equals n, if the measure of big N equals n or 0 and the measure of big N without n equals n minus little n or 0, so if I can establish that a function has the property that it is both n and a singularity, this whole time in all of my notebooks I've been using 0 for a singularity. But I think the wiser idea is, do I use 1 for 1, f of 0 to chi of 0 equals 1. I think I'm wrong in pursuing something here. So I'm considering measure to either be the cardinality of a set, or it could be area of space an object occupies, in which case the measure of it is 0. So if everything can be represented by a set, and we're attempting to describe points with a set, then you need infinite sets. That's what that says. Yeah, I need infinite sets. So this looks really stupid, but in terms of trying to prove theorems, we want to go from consistency plus consistency leads to consistency. So essentially 1 plus 1 maps to 1. Shoot, but I want 1 plus 1 to 1. 1 plus 1 maps to 1. Maps to one expression, one result, one solution, one proof, and it subsumes everything, and then it can't be true. So if something subsumes everything, then it can't be true. Although resonance might subsume everything and be true, because it takes time out depending on the way it interacts with its environment, an object. But so no, I want the measure of 1 equals the measure of 1. This equals was inferred in this direction. I'm not sure if this goes anywhere, but the measure of 2 equals 2, and the measure of 2 equals 1 or 0. The size of the measure of 2 equals 1 or 0. Either we do have a way to measure it or we don't. Special 1, special 0, I can't help it. They have horns. And if we can prove that 1 and 0, that the measure of equals 1 and 0, then we should be able, this should lead us, include that question mark equals 1 leads to question mark equals 1. Special 1. So where am I going? Where am I going on this exploration? The question I still have is, when is depth reversible? I think I should just consider an inverting parentheses. Yeah, it doesn't work. It was still an exploration, but I'm not sure how to deal with this notion of depth and its reversibility in terms of time symmetric processes, ones that loop back and forth with each other. If they're mere symmetric, it should be fine. First off, just a note, an idea I had when I was on my walk, and that is that if we can pin down enough discords, I had to switch pins. If these are the points of discord, then we can create a computer program. F1 and F2 are both file names. We can find the points where they agree, F1 intersect F2, and use this to create maps between related files. This allows for the identification of project assets that are related. So I have a PDF, for example, and I have a video, and I have text notes. So I'm going to use this new notation I just made up. An apostrophe means of. So title of PDF, to title of video, to title of text, and this pattern goes in all directions, giving the result. So the system appends each of the different file names some associated data from each of the other individual files it's linked to. And this is where all of the three different files have different initial name descriptions. They aren't identical. So if I have the title of a longer file with children, let's say title of video. So I have title of video to PDF1, PDF2, and so I pick some aspect of title, and that goes in each of the titles of the PDFs. We call that the descriptive identical with D, and we get PDF1 descriptive of title of video. In PDF2 we get the same descriptive, and I have the arrows going in the wrong direction. Phil, you put the arrows in the wrong direction all the time. But I know I can correct it. There's only two directions, so when I make this mistake, I just sort of keep going and just pray that I maintain symmetry. Okay, and these arrows actually go to title of V when the system, it goes to title of V when the system tries to reconstruct the entire class of objects that relate to a single project. But initially, T of V maps outward to PDF D prime T prime of V, and then it maps back into T of V when we go to try to call the result that is the resonance class for the entire class that is the project. If that doesn't sound confusing, then you're not me. It's a lot simpler than that. It's not simpler. It is just able to be put together in a more succinct way. I know it. And so descriptive D and also T prime in this case would actually, when you went to actually do the operation on T prime, it would get a descriptive from each of the PDFs. I think the best thing we could pass to T of V would be the union minus the intersection. I'm sorry, I get so hasty. Oh shit. Save the tape. I don't want to have to go and do surgery. Be careful. So I think we want the union minus the intersection. Union minus intersection of... Okay.
Yeah.
Love you.
Keep going to company.
You going to Haley's?
I'm gonna go see her get her chip.
Okay, cool. Descriptives. Can you not make these mistakes? Something more intrinsic to just me. It'll take more work to get through this kind of deficiency. So the descriptive of F1. Oh, I just done. Just write it down. Descriptive of PDF sub I. The union minus the intersection contains the smallest set of data that describes the whole system of PDFs. And so we can use this to keep our files tied together in some way that allows us to try to compute when a person is dealing with files that are part of a related, you know what, Microsoft already has this. I wonder how they did the implementation of, do they still have it? They used to call them sets or something. Okay, that's all I wanted to say about that. And the point was, I forgot what I was going to do, but what we can do is we can compute a wave function for all of the different files. Some function that is the sum of waves, like some Fourier thing. And that leads to, say for a single file, the stacking of waves up to some good approximation. And then we look at the intersection of the sum of the waves to give us points of discord of size 1. And so this has size 1. And so these are like individual instances of some aspect of reality. And if we're talking about file names, these points of intersection might be words. And so each of these represent different words that fall out of the wave function or collapse into their specific values upon the intersection of the particular waves. That's enough notes for now.